In this video, I'll go over the answers to Classwork 9. Part A says, suppose a consumer's income is M equals 10, the price of good 1 is 2, and the consumer's demand is given by X1 equals 2 plus M over 5P1. Let P2 represent the composite good. If P1 fell to 1, what is the change to X1 and how much of that change is a substitution effect versus the income effect? So let's just start with what our demand is for this first set of prices. P1 is 2. And remember, the composite good is just your spending on all other goods. So we can say our income was 10, P1 was 2, and so we can find what our consumption of good 1 will be by plugging into that formula. So I'll say our original prices, our X1 will be 2 plus 10 over 5 times 2, which is 2 plus 10 over 10, which is 3. So X1 starts out at 3, and then what is X2, the composite good? How much money are we spending on all other goods? We'll take our income, 10, and we'll subtract our expenditure on good 1, which is we bought 3 of them, and we bought them at a price of 2. So 10 minus 6 is 4. So our initial consumption is 3x1 and 4x2. Well, maybe I want to do a little bit bigger of a diagram here. So if we have, let me just draw kind of a random budget line here. X1, X2, I can be a little bit loosey-goosey here. 3, 4 is where we start out. 3, 4. And then new prices, so P1 falls to 1. Say new price. Now we have, again, plug into this formula to find out the new demand for X1. X1 will be 2 plus, our income is still 10, divided by 5 times 1. So that's 2 plus 2, which is 4. And then X2 is our income minus the expenditure on good 1. We bought 4 of them, and we bought them at a price of 1. So we have $6 left over to spend on other goods. So now we're at the new prices. When the price falls of good 1 to $1, now we buy 4 of good 1 and 6 of good 2. Here's our example of the price falling. Budget constraint where the price is falling for good 1, pivoting out like that. And now we find ourselves at 4, 6, right up here. But the question is, how much of that change is due to the substitution effect? How much of that change is due to the income effect? To find out, we want to break down, we want to decompose this change from 3, 4 to 4, 6 to 2 changes. 1, the substitution effect, and 1, the income effect. I'm going to draw, this will be green here. This will be what I call the substitution effect budget line. Substitution effect budget line. And at this substitution effect, it's gonna have the new prices. It's the same slope as this new price budget line, but it's gonna have M prime. We're not gonna have the same income as in these two budget lines. We're gonna have another income that makes it so that we can just afford the original budget constraint. And so that isolates, that says, how much does our demand change just because of the new prices, and forgetting about the increase in purchasing power that we have. And then once we figure out how much we are substituting, then we're going to add in how much the change to demand happens because of the change to purchasing power. That's the income effect. So what is the question is, we have to figure out what is M prime here. M prime, I just said, kind of a lighter green, I think. Not so light. Okay. M prime makes the original bundle 3, 4, just affordable under the new prices. And the new prices are 1, and then the price of the composite good has always been 1. It's just money spent on other things. So money costs $1. That's why P2 is $1 there. So to figure out what M prime is going to be, we're buying 3 units of good 1 at a price of 1 times 1 plus 4 units of good 2 at a price of 1. So 4 times 1 is $7. We need to reduce our income to $7 and then see what happens to our demand at these new prices. So let's do, this is the substitution effect. X1 is, again, we plug it into this formula, but now considering P1 is 1 and M is M prime, which is 7. So our X1 will be 2 plus M, which is 7, divided by 5 times 1, which is, I'm going to need a calculator. Let's see. Bringing it up on my phone. Okay. 7/5 is 1.4 plus 2 makes it 3.4. So our demand for good 1 becomes 3.4 under substitution effect. And let's see what X2 is. It's our income, 7, minus the expenditure on good 1, which is we bought 3.4 of them at a price of 1. So it's just 7 minus 3.4. 7 minus 3.4, which is 3.6. 3.6. All right, so let's put this in our diagram. The substitution effect led us to, does it make sense that it's on this line? Led us to buying 3.4, yeah, so a little bit more of good 1. And I guess we're actually like super close to this line. And a little bit less of good 2, which makes sense because substitution effect said X1 got relatively cheaper, so we bought more of it. X2 got relatively more expensive, so we bought a little less of it. And so that's the substitution effect, going from 3.4 to 3.4, 3.6. So I'll put that in a color that stands out a little bit more. 3.4, 3.6. So here to here, that's the substitution effect. And then here to here, that's the income effect, right? Because all I'm doing from here to here is shifting out this budget constraint. That's the change in demand due to the higher purchasing power. And so to finally answer this question, I would say I went from 3 to 3.4. That's the substitution effect. So substitution effect was plus 0.4 units of X1. Or it's actually, units of good 1. Good 1. And then the income effect, we went from 3.4 to 4. So we had plus 0.6 of good 1. And in total, of course, we went from 3 to 4, and that's, you can add up the substitution and income effect. We had plus 1 unit of good 1. When the price fell for good 1, we ended up buying 1 more of them. 0.4 of it from the substitution effect and 0.6 of it from the income effect. So that is the answer to question A. Let's move on to question B. So B says, I'm going to make a little room there. Okay. B says, let x1 and x2 be perfect complements like right and left shoes. Recall that indifference curves are L-shaped and utility is given by the minimum of x1 and x2. That is, so if you had, one right shoe and 3 left shoes, your utility would be 1 because you really only have one pair of shoes. So the first part says the demand for goods 1 and 2 can be derived from these two equations. X1 and x2 are the unknowns. First equation is that you want the same number of right and left shoes, so x1 equals x2. It's the first equation. The second equation is that the budget constraints hold with equality. So P1 x1 plus P2 x2 equals M. Solve for x1 to show that for perfect complements, a consumer axes of good 1 and good 2 are a single good with price P1 plus P2. So we have this equation, we have this equation. Let's combine them and solve for x1. So I'm going to have P1 x1 plus P2, and I'm going to put in x1 for x2 because I know that they're equal. I'm combining these two equations. So that'll be x1 equals M. And then I can collect x1 over here. So it's just x1 times P1 plus P2 equals M. And then I have x1 equals M divided by P1 plus P2. And I also know that that's equal to x2 because x1 equals x2. So that's the number of right and left shoes that I'm going to purchase. And you can see it's as if goods 1 and 2 are a single good with this price. I spend all my money. If I have M money to spend on shoes, I'm going to spend it all. And if right and left shoes have different prices, this is how I'm going to do that. I think it makes it a little bit clear to see the example here. If you want to spend $6 on shoes, right shoes cost $1 and left shoes cost $2, how many right shoes will you buy? How many left shoes? So according to what we just derived right here, our x1 would be equal to x2, which is equal to our income, which is 6 here, divided by P1 plus P2. One of them costs $1, the other costs $2, and so 6 divided by 3 will be 2. We're going to buy 2 right shoes and 2 left shoes. Let's make sure that we can afford that. To buy 2 right shoes, that costs us $2. And to buy 2 left shoes, that costs us $4. So yes, that comes right under or equal to the amount of money that we were trying to spend. So, you can think of right and left shoes costing different amounts, or for perfect complements, you would think of, a pair of shoes costs, 1 plus $2, $3. All right. So now we're gonna, in part C, or the third part of question B, take the conditions from the previous problem. If the price of left shoes went down to $1, how many right and left shoes would you buy now? And how many more from the substitution effect versus the income effect? So, price of left shoes falls to $1. Left shoes were $2. So let's see, what are we gonna, so this is I'll label this is the original. And then this is the new, at the new price of 1, now we're going to buy x1 equals x2 equals M, which is still $6, divided by, now the price of shoes is, price of left shoes and price of right shoes is both 1. So 1 plus 1 down here, which is 6 divided by 2 equals 3. So now we're buying 3 right shoes and 3 left shoes after the price went down. So that answers this first part. And then the question is, how many more from the substitution effect versus the income effect? So we're still thinking of this diagram, x1, x2, and we have this first budget constraint, and we're buying, we're buying this, 2, 2. And then we have a second budget constraint right here, and we're going to buy 3, 3. Let me kind of, this is the line x1 equals x2. And we're always, so we're on that line, right? At this first budget constraint, we are here at 2, 2. Now the price of good 1 goes down. So we have a new budget constraint right here. And now we're at 3, 3. And then this is, just to remind you, these are our indifference curves, this L shape. Okay, so the substitution effect asks, we want to draw this substitution effect line. It has the same slope as, it has the same relative prices as the final budget line, but it's going to make the original bundle just affordable. So, maybe we don't even need to go through the process of figuring out what M prime is. We can already see, basically whatever line, if we have any kinds of budget lines along here, we're always tangent to this point. This is always, if this point is affordable, that's always going to be what we're selecting. We want the same amount of x1 and x2. And so here, this is already solved for us, but just by looking at the picture. We know that this substitution, under the substitution effect, I have x1 equals x2 equals 2. My demand for goods 1 and goods 2 does not change for the substitution effect. Substitution effect line. The substitution is 0. And that's because I can't substitute between right and left shoes. I need to get them together. So there's no substitution. When the relative prices are changing between goods 1 and goods 2, I do not substitute in between them because I need to buy equal amounts of them. So there is no substitution effect. I go from buying 2 of each to still buying 2 of each. And then so the increase going from the old budget line, the old budget line to the new one with the lower price for P1 is 100% income effect. My income effect is that I go from 2 units of x1, x2 to 3. So the substitution effect is 0. Income effect, I went from 2 to 3, is 1. Plus 1, plus 0 units of x1 plus 1 x1. So that's the kind of cool result about perfect complements.